Hello everyone, I hope you all are doing well. This side Priya Bhatia, and in this particular video, we will be starting our hands-on implementation of KNN algorithm. So until so far in this module, we have explored each and everything about KNN. We have talked about the mathematical intuition of KNN. We have talked about the optimization of KNN. We have talked about what are the pros and cons of this particular algorithm that we have, and what are the real-time applications, in what scenarios in industry level project we should go for this particular algorithm. I think everything till so far, whatever explanation I have gave you in terms of KNN is pretty much clear to everyone. I believe now it's a good idea to just do the hands-on of this algorithm. And what I'll do is, if you remember in the last part of the modules where we have talked about logistic regression, right? We have done one project by the name of predictive analysis on diabetic data. So what I'll do now is I will try to pick that same data set, that same collab file. And on top of this, as that was a classification problem, we will try to check that, what is the kind of accuracy, what is the kind of confusion metrics in the classification report we are getting if we are applying this on the same data that KNN algorithm. So whatever be the EDS steps we have done, that will remain exactly same. So I'll not repeat those concepts. The only thing which I will do in this video is the model training part. Instead of applying logistic regression, today in the same file, I'll apply the KNN classifier, with the help of which we will be able to understand that how the implementation will be done. So I hope you all are excited with me. So without wasting any time, let's get started. So now, as you can see that I have opened that same file of predictive analysis in diabetes, and I have already uploaded my data. Can you see diabetes.csv? So what I have done is, maybe you can also refer that same file and you can try to click on this runtime and run all the tabs in one go. So what will happen is, once you have file available with you, and because you all remember we have already done the complete ED of this file, so we will not repeat that concept again. We will directly try to use that filtered data that we have, which is having lesser outliers, which is having a balanced data. All these things, keeping that in mind, we will try to use the KNN now. So here, just to give you a brief overview, we have imported all the libraries. We have tried to create a data frame. After that, you can see all these are the steps of understanding the data, to check the null values are there or not, to check the top 20 values. Then if you remember, we have tried to evaluate the correlation coefficient, just to check that whether the two variables or two features in our data is highly correlated or not. If yes, then in that case, definitely the question is to remove at least any one of them feature. But in this scenario, we have observed that there is no as such features that we have which is having a very high correlation coefficient, right? After that, we have seen the statistical description of that data. We have tried to do the data imputation of those zeros values, because anyhow we have observed in that particular sessions that in this particular data, null values are not there. That's a good thing. But the bad thing is it contains zeros, which doesn't make sense, because any person who is having a BP or doesn't have a BP cannot have a value as 0. That's not a normal value, right? So that is something which we have observed. This similar thing we have observed for various features. So we have done that zeros imputation with either mean, median or mode. After that, if you will be able to observe, we have further discussed about the imputations, then the outlier detection via box plot. We have seen multiple ways to remove the outliers, maybe via z-score, maybe via box plot. Everything we have discussed. After that, we have done the scaling part, and after that, we have tried to apply the model splitting in the training and testing. And after that, we have tried to use the approach of data imbalancing. That's where we have applied a SMOTE technique, which is, again, if you remember in the previous videos, I have given you a task of doing your own research, that how is this SMOTE technique is using the KNN concept. I hope that you have done that, right? After that, we have done the predictions part, and then we have seen how we can save the file, pickle file, how we can load that. That's completely fine. Today's task is to directly jump towards a model training, where what I'll do is I'll try to apply the, first of all, KNN classifier model on top of this particular data that we have. So what we will do, we will be having KNN. Now, in order to apply this KNN classifier, the important thing to understand is from which particular package it is available. So you can see it's available in sklearn.neighbors. I'm just copying it out. And what I'll do is I'll just say from sklearn.neighbors, just import the package name, the function name is kneighbors classifier. So I'm again just copying from this kneighbors classifier. So what I'll do is I'll just call this function. Now when you're calling this function, you know, because we already have discussed in our previous sessions, that by default it will take the value of n underscore neighbors as 5. But it's a very important parameter in KNN. I would say there are 3 important parameters in the complete KNN function that we have. One is the neighbors, another one is the algorithm, which is, I think auto is a preferable choice, because depending upon as per data, it will automatically take whether we should go for, you know, ball tree, or we should go for KD tree, or we should go for the brute force approach. And the third important thing is the p-value, which is by default Euclidean. For now, I am taking the default parameters. But in future, when we will be discussing about the hyperparameter module, I'll try to show you that the same KNN algorithm, how can I tune on this similar data set. But for now, let's take the default parameters, means it will take the number of neighbors as 5, it will take the distance metric as Euclidean, it will take the default value of the algorithm as auto. Now, let's move ahead because we want to apply the metrics part. So, although I think it is already imported, but without taking any chance, I'm importing it here from sklearn.metrics. I'm just doing one thing. I'm importing the classification underscore report. Also, I'm importing the confusion underscore metrics, because you know in the classification problem, these 2 metrics are really important and plays a very significant role. There is some issue what they are saying, confusion metric, maybe the spelling is wrong. Confusion underscore metrics. It should be metrics, right? Metrics. Now it should be fine. Let's see. After that, we will try to fit our model on the training data. So now if you remember, our training data variable name is, let me see where we have applied the logistic regression algorithm. We will pick up the same data, right? The training data is this, right? So we have solved the problem of data imbalancing via SMOTE technique. So what we can do here is we can try to use that same samples here as well, right? We will try to fit our data, fit our model. And once it is done, maybe what we can do is, let's first of all do this. Check the model prediction. Now you can see it just takes few milliseconds and it is done. So model prediction. But now I hope you know that what is the reason behind that, right? So what I can do is y underscore prediction, and I'll say underscore KNN, so that it will indicate that we are working for KNN here. Now what I can do, I can say KNN is my model name, dot predict is the function name that we have, and let's try to see what is the variable that we have for, I think y underscore test is the accuracy score. Just let me check. X underscore test we have, I believe so. So when we are doing a prediction of the logistic regression, yes, we are entering the X underscore test. So let's enter the same thing, that same variable name, X underscore test. And once it is done, let's try to look for the Y underscore prediction underscore KNN. So here you will be able to see we are having now predictions, either it will be 0 or 1, indicating that a patient is diabetic or not, right? So now let's say I want to print the confusion metrics here. So how it will be done? So you can say print confusion metrics, and what you can do is you can just try to print and call the function name confusion underscore metrics by passing the 2 important parameters, y underscore test and y underscore prediction underscore KNN. And you will be able to see a beautiful confusion matrix indicating the true positives, true negatives, false positives and false negatives. If there is anyone who is not aware about these key terms which I'm talking about, please refer my videos of logistic regression. Already everything I have covered up in that particular module itself. And I told you in that module itself that this explanation is equally valuable for all the classification algorithms that we covered up in the upcoming module. So I hope it makes sense to everyone that why I said that point, right? Similarly, let's say I want to print the classification report. So what I can do is I can say classification report, and after that I can print a classification underscore report, and inside that you can mention y underscore test under comma, and again y underscore prediction underscore KNN. So you can just print that. So you will be able to get the complete end-to-end idea that, okay, this is the precision, this is the recall, this is the F1 score for 0 class. Similarly, for 1 class, for the accuracy part, what is the macro average, weighted average, everything in one go, you will be able to clearly get that point, right? So this is how basically the KNN classifier works, right? It's very easy, right? We just have to import the specific function, and after that, we just have to call it. We just have to fit it on the training data, and the prediction is very, very simple. Now you can ask me one question that, Priya, in the complete task, you have just shown us that how the k-neighbors classifier works. What if we will be having a problem of regression? Because you told us that, regression problem also can easily solve by taking out the average. So for that, you can just refer sklearn. KNN regressor is the algorithm name. So if you can just open the documentation of this, you will be able to clearly see that instead of just calling that function name as k-neighbors classifier, in case of a regression problem, we will call k-neighbors regressor. The default value will remain same, right? Algorithms part will remain same. The distance metrics will remain same. So it's like everything and anything is similar only. It's just that internal thing will get changed because here we're trying to solve a regression based problem. So you can see the target is predicted by local interpolation of the targets associated with the nearest neighbors in the training set. So basically what will happen is, definitely, as I told you, that it will first of all try to see what is the value of k, take those values, take the mean or the average of that to give us the final outcome. That is how basically the internal flow will go. So in future, if let's say you will be having a regression problem, so instead of just calling this k-neighbors classifier, what you can do is, let me just copy this out. You just have to call this k-neighbors regressor, okay? And similar things you will do, whatever things I have done here, you will have to call the function k-neighbors classifier. You have to, let me just remove this. You have to use that fit method only to fit the data. You have to use this prediction method only to predict the values of the regressor part. Definitely, it will not be 0 and 1. It will be a continuous number which you will be able to achieve. And after that, definitely, because that was a regression problem, so metrics will get changed. Maybe you can measure via MSE or RMSE, right? Or MAE, whatever you have seen in other regression algorithms that we have. Same metrics you can use in this regression part as well, right? So everything will remain same. The flow will remain same. The only contextual difference will be the different function call which we have. So I hope that with this, you will get the clarity that how can we implement the KNN algorithm. So now I hope that you will be able to get a clear-cut end-to-end idea behind this KNN algorithm as well, with the hands-on implementation also. And you have enjoyed this complete module of KNN as well. In the upcoming module, we are starting our clustering algorithms part, where we will discuss different types of clustering algorithms that we have. So it's a separate module altogether. Until so far, we have focused on supervised learning, meaning that target column will be available to us. But now we will jump towards the unsupervised learning, where the target column is not available to us. And let's try to understand at that point of scenario how basically we can solve any scenario, any situation, what kind of algorithms can we apply. Everything and anything we will discuss in a great detail. So with this, let's end today's video. I'll see you all in the upcoming module. Bye bye everyone. See ya.